Before we do the next question, let's just do a little bit of revision around halides. If we have concentrated sulfuric acid with sodium fluoride, a fluoride, it makes white steamy fumes of hydrogen fluoride and something called hydrogen sulfate, sodium hydrogen sulfate. In this case, if you have a look at the F has received an H. It's actually received an H plus because F will be F minus, H plus F minus. So it's received an H plus from the sulfuric acid. So the sulfuric acid has donated an H plus. Something that donates an H plus is called an acid. So the sulfuric acid is acting as an acid to turn F minus into H plus F minus, or HF. Similarly, exactly the same thing with sodium chloride, but you'd make hydrogen chloride as white steamy fumes, and sodium hydrogen sulfate again, and again the sulfuric acid is acting as an acid, donating H plus to the Cl minus to form H plus Cl minus, or HCl, hydrogen chloride. And the reactions stop here. The sulfuric acid isn't a strong enough oxidizing agent to do the next step. Let's have a look at sulfuric acid acting as an oxidizing agent. So with sodium bromide, the same thing happens again. We get the sulfuric acid acting as an acid, forming HBr as steamy fumes and sodium hydrogen sulfate. But then we get another step. The sulfuric acid, the concentrated sulfuric acid, is a strong enough oxidizing agent to be able to take this HBr and to oxidize it. Let's work out what oxidation is. In here we've got H plus Br minus, so the oxidation state of an H is usually +1, unless it's with something like sodium hydride, NaH, where the sodium is in +1 and the H is as -1. Usually a H is as +1, and so the Br is -1 oxidation state. When it's on its own as an element bonded to no other atoms, it's 0, so it's gone from -1 to 0. It's been oxidized, so the number has gone up from -1 up to 0. It's been oxidized. And bromine is a brown liquid, but actually, if it's slightly warm, it will form a brown-orange solution, or orange fumes. So it can form orange fumes or an orangey solution, a browny orange solution. So it's normally a brown liquid on its own, but if it's in solution, it might be slightly orangey, a brown solution, orangey fumes. It will also produce sulfur dioxide, which is an acidic choking gas, and some water as well. In this case, the sulfuric acid has acted as an acid, but now it's acted as an oxidizing agent, oxidizing the HBr to Br2. Sodium iodide, similar reaction again. The concentrated sulfuric acid making hydrogen iodide as steamy fumes, white steamy fumes, sodium hydrogen sulfate. It's acting as an acid, and again, just as in the case of HBr, it can go further. So the concentrated sulfuric acid can act as an oxidizing agent and oxidize the H plus I minus in there, -1 oxidation state. On its own there as an element I2, not bonded to any other atoms, oxidation state is 0, -1 up to 0, it means it's been oxidized, and it forms I2. Now that's a black solid. So that's a black solid, and it'll also make hydrogen sulfide, which smells of bad eggs. It's in stink bombs, hydrogen sulfide, and some water. It can also at the same time go again another reaction. You don't need to know the equation for that, but it can actually make a yellow solid called sulfur. So it can go a little bit further and oxidize this hydrogen sulfide to form sulfur. In this case, it's acting as an oxidizing agent because it's oxidizing the H plus I minus to make I2, oxidation state -1 to 0. A little bit about chlorine to remember. Chlorine in water will make hydrochloric acid and something called hypochlorous acid, an equation you need to know. It makes a green solution, and the green colour in the solution is any leftover chlorine. That's a green gas. So if you're asked what the green colour is left in this solution, why it's still green, because each of these are colourless, hydrochloric acid and hypochlorous acid are colourless, it's because there's usually some excess chlorine dissolved in the water. In bright sunlight, it reacts with water to form hydrochloric acid and oxygen, and chlorine is used to treat water and kill bacteria. Common question is, chlorine's toxic, so why Why is it put in water? How can we get away with it treating water if chlorine is toxic? The amounts are so low that the benefits to our health in killing the bacteria outweigh its toxic effects. Let's have a look at the question then now. Question 2.7. Concentrated sulfuric acid reacts with sodium chloride. Give the observation. So we've already talked about the fact that sulfuric acid acts as an acid in the first instance, and with sodium chloride and sodium fluoride it won't act as an oxidizing agent. It's not a strong enough oxidizing agent to be able to turn Cl- into Cl2, so it only acts as an acid with sodium chloride and sodium fluoride. Observation, white steamy fumes, hydrogen chloride. Role of sulfuric acid is an acid, so it can only be an acid, act as an acid with sodium chloride and sodium fluoride, because as we say, the concentrated sulfuric acid is not a strong enough oxidizing agent to turn Cl- -1 oxidation state into chlorine gas Cl2. However, with sodium iodide and sodium bromide, it is a strong enough oxidizing agent to turn Br- into Br2 and I- into I2. So observations, the black solid is iodine, a black solid as we've seen previously. The yellow solid, if it were to make a yellow solid, would be sulfur. It's making a gas with the smell of bad eggs. That's a clue. That's your hydrogen sulfide. Hydrogen sulfide as a gas.